My name is Brooke Akins, and on behalf of Q1 Productions, I'd like to welcome you to this afternoon's webinar, and thank you for joining us. Today we'll be discussing using information management to support data-driven actions in the life science industry. This webinar has been developed off of attendee comments and feedback from our most recent annual Life Science Enterprise IT and Cloud Computing Forum in Phoenix, Arizona. We're very lucky to have Mr. Manoj Vig, Associate Director of Information Technology at Shire Pharmaceuticals with us today, and he'll be providing us with insight into the information management lifecycle as it relates to core business processes, as well as discuss an integrated approach of how data is collected, managed, and then distributed to actual decision makers. There will be an opportunity to submit questions to Manoj once he's finished speaking, and you're able to do this via the questions feature in your GoToMeeting toolbar on the right-hand side of your screen. Questions will be answered in the order they are submitted, and please be as specific as possible when submitting your questions. I do encourage you to include examples to better assist our presenter in thoroughly answering your questions. And again, I do know that we have a team participating with us as well today. If you don't have access to your GoToMeeting toolbar, please feel free to send those questions directly to me via email at webinars@q1productions.com. Please also note that we'll be holding our first annual Clinical Data Management Innovation Conference on October 28th and 29th in Alexandria, Virginia. The meeting will focus on preserving the integrity and quality of captured data through the utilization of innovative technologies and electronic data capture systems while effectively managing limited resources and oversight of outsourced clinical data management. More information on all upcoming events is available at q1productions.com. But without further ado, I'd like to introduce our presenter today, Manoj Vig. Manoj has more than 13 years of experience in business intelligence, data integration, information architecture, and management. He spent most of his professional career working with pharmaceutical companies in various roles. He's also worked for healthcare insurance companies. Manoj is currently with Shire Pharmaceuticals as the Associate Director of Data Integration and Business Intelligence. He is passionate about enterprise information management and architecture and finding innovative ways to use information frameworks to support organizational business models. He is a thought leader in his domain and has helped several organizations in achieving full potential of their business model by adopting meaningful information management and business intelligence strategies. And at this time, it is my honor and pleasure to hand it over to our presenter today, Manoj Vig. Manoj, welcome. The floor is yours.
Thank you so much, Brooke, for such a nice introduction. And I also like to welcome everybody to today's webinar. A couple of things from my side as well. While working on this presentation for this webinar, I kind of ended up adding more content to my original presentation that I'll be presenting today. Basically at the end of this presentation, you guys will get the PowerPoint deck that we are presenting here. But should you have interest in taking a look at the extended version, feel free to get in touch with me either by just sending me an email, or you could facilitate that communication through Brooke, and I'll be more than happy to share that extended version of document with you guys as well. In terms of today's presentation, it is definitely my hope that by the end of this presentation, you will have more appreciation on what information management is all about, specifically in context of life sciences industry, and it should also reiterate the importance of work that we all are doing in our respective organization. That being said, let's go ahead and take a look at the structure of this webinar. So really, webinar is divided into three different categories. We'll talk about what is information and why is it important to manage it. We probably will spend 7-8 minutes talking about that just to set the scene for the rest of the presentation. And then we'll start talking about data lifecycle, collection, maturing, securing, and managing the data. This is where we'll be spending a significant amount of time. We'll be talking about building blocks of a robust data management framework, if you will, which is required to really support a robust and open information management ecosystem. We'll be talking about metadata management, data quality, a little bit about data profile, as well as about the impact of unstructured data. And then finally, we'll discuss analytics and how you can use analytics to make meaningful business decisions. Big data is really not a prime focus of this conversation, but because it's such a disruptive phenomena, there will be some references to big data. We'll be talking a little bit about big data related technologies, as well as some strategic recommendations that I like to share with you guys. So as Brooke has already explained, I work for Shar Pharmaceuticals, and today's webinar that I'm doing in my own personal capacity. I'm not representing Shar Pharmaceutical in any shape or form. Content that you'll be seeing basically is collection of my personal opinion, as well as ideas, concepts, and direction, technology or otherwise, or all my thoughts, my personal thoughts, and Shar is definitely not obligated to adopt any of those trends or directions. So let's talk about what is information and why is it important to manage it. So if you look at this picture is an attempt to establish the relationship between 4 different aspects of information management, if you will. Data's relationship with information, and then information's relationship with knowledge, and finally knowledge relationship with wisdom. And as you move towards the aspect of wisdom, you see that business value increases. So data is everywhere. You have data within your organization, you have data outside of your organization. When one of your staff members goes to an ERP system and inserts a record, that person creates the data. When you go and tweet something on Twitter, you create some data. And data is good as well as bad. So there is some good data and there is some bad data, which also means that there's a lot of noise in this data. The difference between data and information is that when you put together tools, process, and technology in place to filter out the noise and collect the signals out of that data and put that in a specific business context, that's where your business users will be able to leverage on the data that has been collected in form of information. And that's where people will start making certain meaningful business decisions. Now, when a specific business user of yours use this information again and again, this person starts seeing a pattern. And that pattern hopefully will help your business user acquire some knowledge that eventually will get to a point of wisdom where your business leader or your business user will be able to take certain decision to adjust your business strategy, for example, in a purposeful way. So just to put that in a context, let's take a hypothetical example that there's an ongoing clinical trial going on of a specific product within your organization. And this is the second attempt of the clinical trial for this particular product. In the past, that clinical trial failed for certain reasons. So as this clinical trial moves forward, one of your lab worker is taking the reading of results and inserting that information in your clinical trial management system. That is an example of data. That data is really not going to be able to answer many questions that your clinical trial manager might have. Maybe that clinical trial manager is looking for certain kind of trend in terms of understanding how your clinical trial is moving forward. But if you collect that data over a period of time, let's say 2 months or 3 months period of time, your clinical trial manager will be able to see a pattern in terms of how that clinical trial is progressing. And then to make it better, if you can really somehow integrate this data or information with the clinical trial that took place in the past, one that did not go very well, now your clinical trial manager will be able to really establish some correlation and comparison, and that is the whole thing with information. That's where this person starts seeing some patterns and start making some decisions. One thing that has been seen in this context is that if you look at the mature organizations, you will see that not only these organizations have a very robust data management and information management framework, but they also are trying to work towards creating a knowledge management framework. What that means is that they're trying to encourage their internal business stakeholders to share information between various internal stakeholders as well as external stakeholders, so that you can maximize the value of that data and information. So generally speaking, there are 5 data domains that your data can be divided into. Again, the whole notion of enterprise information management is evolving, and nobody can really say that this is the final list. But in generally speaking, there are 5 data domains: metadata, master data, operational data, unstructured data, and analytical data. So metadata is something that will be used to make sense of data. It establishes a common understanding around what data you have, how it should be used, what is the characteristic of this data. And then there's a classification in terms of business metadata versus technical metadata. We'll be discussing metadata further during this presentation. Then you have master data. Master data is basically data set that is absolutely critical for your business to run and operate properly in a digital world. Some common examples could be customers, products, accounts, location. Again, this is one area that needs to be put in context of your specific business model. These are just some general examples, but there may be some other kind of data elements that is critical for your specific organization, and if that is the case, then that should be part of your master data management framework as well. Now, we all have heard a lot about single version of truth that we all are looking for from our information management systems, and master data is the core foundation of facilitating that notion. Then you have operational data. As of today, in the year 2013, operational data mostly reflects your transaction history. This is where everything starts. This is where data is created. It could be internal, it could be external. Again, going back to the previous example, one of your salesperson inserting a record in your CRM system will be an example of operational data, or a record that is being inserted in your supply chain system will be an example of your operational data. And then unstructured data. Now, unstructured data is definitely not a new concept or not a new phenomenon, but it's really heating up now because people have started realizing that this is really untapped wealth of information. 75% of data within your organization is still living in unstructured world. Some examples of that would be your email documents, your scanned documents, scanned contracts, and vendor data that you probably get from some of your external partners. I mean, unstructured data is one topic that we'll be discussing in significant detail as we move forward with this presentation. And then finally, you have analytical data. So this is the data that is closest to be called information. This is what you want to deliver to your business users so that they can make their own business decisions. This is clean, transformed, well-governed, well-secured data, and it is strategic in nature, and it should be considered part of your business model. So let's dive right into the second segment of our presentation, which is about data lifecycle, collection, maturing, securing, and then managing it. So before we move forward, let's spend a couple of minutes and talk about data lifecycle. What is data lifecycle and how it should be envisioned? A lot has been said and written about the fact that data is a true asset. But in many organizations, we don't really treat data as an asset. If data is true asset, then it should be managed like a true asset in every step of its data lifecycle. So what you see here is a very simple example of how data's lifecycle should look like, starting with creation and ending with disposition. So Creation can be, again, internal or external. Again, somebody inserting a record in ERP system, or somebody actually inserting a record in custom application will be creating the data for you. When it comes to acquisition, there are a few things that you need to keep in mind. Acquisition is all about capturing the data that you think you need to really support your information management needs. How the way you should do acquisition would depend largely upon a couple of things. What your business model is, what's your information management strategy is, or perhaps what is the problem in hand. So it's possible that you are trying to build a specific data warehouse within your organization to answer certain already established business questions, and in that case you will be collecting selective data. So you may just go to some of the internal data sources that you have and pick the data that you're looking for. You may need some external data as well, such as some data from Salesforce.com, or you may need some procured data as well, and you may just go and get that selective data within your staging area. Or maybe you're trying to do something with big data. Maybe you're trying to put together some kind of advanced analytical framework, where your notion is that I'm going to try and get as much data as possible, and will use my big data technologies and will explore this data to identify some patterns. Maybe you want to do some kind of predictive analytics on top of that. And in that case, you will try to acquire as much of data as possible. Though one thing you need to keep in mind is that if you're trying to put together some kind of big data framework, then you definitely need to understand that there is a cost associated with storage of all this data, the wealth of data that you will be collecting, and you need to justify it against the value proposition. So once you acquire this data, you start assessment phase. Within this phase, you basically assess this data for its current health, fit for purpose and usability. And you also scan through this data to really understand if there is subset of this data that should be part of your master data management. Maybe there is some data that should have some kind of integration with your metadata management. And finally, you try to understand the quality of this data. And there's so many different ways people do that. A lot of people do it manually. Some people use enterprise data integration tools and technologies available to run a data profile and try and understand if there are some data anomalies available within your data. This is a very important topic, data profile that is, and we'll be talking more about this in one of the slides. But this phase will not only give you a sense of the current health of your data, but will also give you an opportunity to really get in touch with your appropriate business stakeholders and try to understand how that data anomaly should be handled or managed, and that should be done in your quality framework phase. So you find some data anomalies and you work with your business stakeholders and you make a decision that either you drop that set of data because that data is so bad that it's not going to add any value, or you come up with some kind of data quality related business rule. So you come up with some kind of cleansing rule, you come up with some kind of standardization rules. In the next phase, when you start doing the integration of data, that's where most of your IT activities will take place. So you will get the data from various sources and you start doing the transformation, you start doing the cleansing, you apply your data quality rules, and you aggregate that data, you summarize that data, and you make that data ready to be used by your information delivery platform or information delivery layer, which is what delivery and retention is all about. That is the data that will be pushed to your business stakeholders, and they will be using that data in various information delivery channels such as reports, scorecard, visualization, mobile reports, mobile applications, even on web applications, even on websites. And then finally, you start thinking about archiving that data and disposition of that data. So again, going back to data is a true asset analogy. Just like any asset, with time, data will also go through the process of depreciation. 6 months down the line, 8 months down the line, certain set of data will start losing its business value and will start becoming more of a liability. At that point in time, you really have to figure out if this is the time to archive that data. When you are considering archiving the data, you have to keep in mind that you're not really destroying this data. Data will move away from your main information delivery focus and will live in an archive area where it can be retrieved later should there be need, such as some kind of internal or external audit. And finally, you start thinking about disposition of that data. Now, when it comes to disposition of data, you need to make sure that you are complying with internal as well as external regulations. There may be some regulation that would direct you to keep certain kind of data available for a certain period of time, such as FDA regulates that clinical trial data related to specific type of or specific category of products should be retained for 9 years. And the whole life cycle should be governed by your data management policies as well as your data governance framework within your organization. So speaking of data management policies, now data management policies are extremely critical. It is considered, in my view, as the most fundamental element of your data management infrastructure. But a lot of times people just ignore the value proposition of data management policies. Again, this is an evolving topic. It's an evolving process. You can't really define data management policy for every possible scenario, which is why it should be part of your continuous improvement framework. And really speaking, you can divide your data management policies in 4 different categories. What are your classification policies? What are your security policies? What are your life cycle policies? And what are your delivery policies? So let's take 3 examples of these different categories. In terms of classification, how do you really determine sensitive versus non-sensitive data? Keep in mind that classification and classification policies are probably more important than the rest of the 3, because the rest of the 3 would depend on classification of information and data elements. So you may have a scenario where within your organization you may want to mask all kinds of social security number, whether it's your internal employee social security number or your customer social security number, or maybe your physician and patient data. So what policies should be in place to really make that determination? You may have a scenario with master data elements. So you have data coming in from your external sources, you have data coming in from your internal sources. What should be your policy to determine if there is subset in that data that should be part of your master data element? And if so, then what subsequent policies you should introduce to manage that master data element? And then you may also have some location-based requirements. So one example that comes in mind is United States European Union Safe Harbor policy. This is a policy or regulation driven by European Union, where a direction is that a personal information of physicians and patients generated or originated rather from European Union should be stored only within European Union data centers, which means you cannot store that information in US-based data centers. So how do you really determine data sets for that? So you need some robust policies around that. And then some general life cycle policies as well. What to retain and what to archive, at what point in time you start archiving. If you're archiving, how long you archive. What should be your value assessment policy? So at what point in time you start your determination process that information that was archived has kind of lost its value, it's not going to be required for any kind of audit, and at that point in time it becomes a candidate for disposition. And then disposition itself, what should be your policies around that? Should you just go ahead and physically destroy the data, or should you take a tape backup and then destroy the data? And then security is a huge topic. In today's world, everybody is connected with each other. We all have our mobile devices. How do you really put together policies around ensuring that your data is secured? There may be some storage related consideration. So for example, like so many other organizations, if your organization is also actively involved in integrating data coming and going to cloud, then you may have a question to answer there, that what kind of data can be stored in cloud-based resources, and what kind of data should be stored internally, what kind of data should be masked, and on how many levels it should be masked. And then there's a question of ownership and usage, which hopefully will be answered by your data governance framework. Who owns a specific data set, and if it's a sensitive data set and a user like me wants some access on that particular data, what should be the approval process around that? And finally, mobile usage management. This is obviously a very hot topic. We all have mobile devices, and a lot of us, including myself actually, believe that mobile devices make you more productive. So it's a very common scenario that you will have somebody from your sales force who wants to use a mobile application or a mobile analytics on their mobile devices. But what you really do if this person is sitting in airport lounge and trying to do some analytics on a mobile device, and just forgets to pick that mobile device and just loses that mobile device. Do you need some kind of mobile device management architecture in place then, so that you can just wipe out that mobile device? Or should you even think about preventing your users from caching that information in their mobile device, so that the impact of such a scenario can be reduced? So there are certain questions that needs to be answered on the from the security aspect. And then finally, delivery of information. External distribution. There may be a scenario, and this is a very common scenario, at least in pharmaceutical industries, that you have to share your information with certain business partners. So when you're doing that, what should be your policies around that? Are there specific technical protocols that you should be using to distribute that data? Should there be some kind of encryption around that data? Or should there be some kind of even governance policy around that? So should there be a approval process that people need to go through before you start delivering that information to your external partners? And then finally, how about managing delivery on analytics and reports? How do you ensure that sales director of Northeast America for product A is not able to run an analytics on sales director of the same product of Midwest, unless, of course, there is a specific reason. So how do you really manage that row-level security? So as you can appreciate from this slide, that data management policies are right at the heart of information security as well as data governance model. And that brings us to the topic of metadata. So metadata is basically considered the foundation of information infrastructure. In simple terms, if you go on Google and try to do a search on metadata, the definition that you will see most often is that it's data about data. Well, it is data about data, but it actually does more than just telling you what data you have and what are the basic characteristics of your data. It establishes a complete personality of your data. And metadata is something that actually is created as soon as your data is created. It helps establish a common understanding of various aspects of data, which is why it also helps you with a data governance vision that you may have within your organization. Now, one question that always comes up and is slightly confusing in nature is, how about metadata management strategy? Do you need a separate metadata management strategy, or metadata management should be just a subset of some kind of data integration, business intelligence strategy? Now, for people like me who grew up in data warehouse and business intelligence environment, it is very important to realize the value and scope of metadata. Metadata is everywhere. It goes beyond the scope of data warehouse. It goes beyond the scope of business intelligence as well as analytics. You create metadata when somebody comes to your company's website and clicks on 3 different places. You have metadata created by your ERP system, your CRM systems, your cloud systems, as well as your custom and standard web application, your content management systems. So the scope of metadata management can be really seen and felt on enterprise level, which is why you should have a separate metadata management strategy. And like I said, that it is absolutely critical for the realization of data governance vision as well. There cannot be a robust, successful data governance model in absence of metadata management infrastructure and framework. And then it is holy grail of consistency. Again, it shows you the symptom of being so close to data governance. So let's take an example here. In the pharmaceutical world, for example, you have a term market share, right? Now, market share is a term that is being used by multiple business units within the organization. So sales uses this term as well as marketing uses this term. And they both may have their own definition around this, and most likely they will have their own definition around that. So how do you really figure out which definition is right definition? And what you want to do is you want to understand the right definition and store that definition in your metadata management repository so that across the board you're using the right definition. At that point in time, you can use your metadata management framework with the help of your data governance professionals and try to have trigger a discussion around that and try to understand which definition should be right definition from enterprise point of view. And maybe both definitions are right definition. Maybe marketing has their own perspective, which is a legitimate perspective, and sales have their own perspective, which is also a legitimate perspective. So in that particular scenario, question is that when to use what definition, and what would you do if you were creating, let's say, a scorecard or dashboard for your CFO. Now, CFO may want to get information from both sides of the world. So which definition would you use in that case? So at the end of the day, as you can see, that metadata management in conjunction with data governance would be required to really establish some consistency around core business terms within your business. Let's talk about some of the applications of metadata management. There are plenty of applications. One of the most basic one that you would see is data lineage. So metadata management will facilitate a process for you where you can track down the flow of data from source to information delivery layer, and you can do it backwards or otherwise. So you may, for example, take a dashboard and you see a couple of attributes that have been presented in that dashboard, and then you can track it back to the middle layer where that particular attribute was calculated, a quality framework layer where that particular attribute was cleansed, as well as you can go to the actual source where that information was created. And there's so many practical usage of this kind of situation. I'll give you an example. This is basically a real-world example. Speaking of data quality and speaking of data governance, it's quite natural to imagine that not every element can be governed, and the data that is being governed will be given special attention in terms of including the data quality. So there was this scenario where a particular compliance manager was actually creating some compliance reports and filing those reports, but this person was using a particular data set that looked very similar to what was governed, but it was not governed data, which also means that there were quality problems with that particular data. This was caught by doing a reverse lineage from a report that this person was sending out on a periodic basis. So you did the lineage, and it went from one layer to second layer to third layer, and what came light was that this is not governed data. So what happened as a result of that, a conversation came up where IT and this compliance manager started talking about the reason why this person was not using governed data, was using a different set of data. and as a result of that, IT decided to include those data elements as well in the governance scope. So this is a great example of what data lineage can do for you. Impact analysis. So how many times we have seen a scenario in IT where one of your enterprise data modeler decided to change a particular column in enterprise data model, and then that broke multiple downstream systems, multiple reports, multiple dashboards. That is something that can be avoided by using impact analysis functionality, because most of the metadata management tools will give you ability where before making that particular change, this enterprise data modeler can run an impact analysis, and it will tell you exactly what artifacts will be impacted and how they will be impacted by this specific change. So at the end of the day, by doing these things, not only you are reducing the risk of breaking other already live applications, but you're also increasing the project delivery and information delivery speed. And then there's this question of business glossary and source identification. I have seen it more than once. I'm sure some of you have also experienced that multi-million-dollar projects actually did not get to desired destination because of a very basic fundamental mistake. At the beginning of the project, people did not make enough effort to identify right source of information that was being pulled in. And that doesn't really sound like rocket science, but it could be a rocket science if you're talking about a Fortune 50 company which has a very complex web of multiple data sources. That is something that can easily be sorted out by a robust metadata management framework. And then finally, business glossary. Metadata repository will give you ability to store your most critical business terms along with their appropriate usage, as well as a link to technical data elements that have been used to really create that business term in a digital way, which will not only help your business users and business stakeholders, but will also help your current and future staff. So this brings us to the next section of our presentation, which is data quality. So we'll be spending around 10, 12 minutes, 15 minutes probably talking about data quality. So why is data quality so important? Well, in a very simple term, if you just look at this picture, it should be able to explain why we need to worry about data quality so much. Quality of data will impact quality of information that is being provided to your business users. And if there are quality problems in information that is being provided, that will impact quality of decisions in a negative way. And if you're going to take actions based on those decisions, you definitely are not going to get the result that you are looking for. So in a very simple term, you cannot really establish trust in the information that you are using to make your business decision in absence of high quality data. But it also encourages fact-based decision making. So to that point, what you will see is that there is a cultural shift going on in the industry right now. More and more companies are moving away from hunch-based, guess-based decision making towards fact-based, data-driven decision making, and that is a great thing. And there's several reasons behind that. There's several things that are fueling that notion. But high quality of data and high quality of information and availability of high quality of information is one of those several factors. So think about again, just to put that in context, hypothetically, you have two executives within your organization, and one believes in making business decisions totally based on facts, and is using really high quality data and high quality information to make that decision. The second person, though, has good intention and has a really robust business experience, likes to make business decision based on his or her own opinion. And at the end of the day, what they say is that executive A is able to get desired result on consistent basis versus executive B, which eventually will trigger the question in mind of executive B Then why is it that I'm not getting the desired results than in comparison of executive A? And then again, going back to the same analogy, data is true asset. Well, the fact is that trusted data is a true asset. Data with quality problem is really not an asset. As a matter of fact, it becomes liability. And then so many times we all have heard this, that business and IT don't really get along well. Business complains that IT will never deliver anything on time, and if they will, then they deliver something else than what I was looking for. And IT says that business has no idea what they're asking for, so don't blame us. As a byproduct of the data quality programs and data quality framework within an organization, simply because the way data quality works, keep in mind that data quality is something that should be defined and owned by business and should be supported by IT. Because of that reason, it requires business and IT to work very closely. It requires these two groups to really form a collaboration, to form a partnership. That's the only way you can have a successful quality framework within your organization. Now, if you really have this kind of partnership between business and IT as a consequence of quality framework or quality program that you have introduced, what's going to happen is that business and IT will also start seeing other areas where similar kind of partnership and collaboration can really help maximize the value of data and information. And then, of course, it helps with proactive risk management because you are taking your decision based on information and data that has been, that reflects what happened in the past, that could be used as lessons learned and can be applied to current and future business decisions that are needed to be made. And then, speaking of life sciences industry, whether it's pharmaceutical industry or medical device or biotech or any other evolving industry, it's a heavily regulated industry for all right reasons. Audit requirements are extremely strict, and that is another reason why you really want to make sure that you're dealing with high quality data. Last thing you want is to file a report with FDA which has data quality problem. In pharmaceutical world, there is something called adverse effect regulation or compliance regulation that FDA has for organizations within the United States, where any adverse effect reported by a consumer or a prescriber of your product should be reported to FDA in a timely fashion. Just imagine the consequences that your organization may have to deal with if you're filing that report with the data that has quality problem. So before we move forward, just like life cycle of data, let's take a quick look at life cycle of data quality as well. One thing that we all need to keep in mind is that data quality should not be seen as a project. It should not have, it should be actually seen as part of your continuous improvement framework. It should be seen as more of a business process or function. It is possible that, like so many other organizations, in your organization also, data quality started as part of a project scope or as a sub-part of a project. But eventually you want to really take a step back and try and create an enterprise-wide data quality framework to really get the real value out of data quality related principles. So that being said, the complete life cycle can be divided into 4 different categories: assessment, define, act, and learn. And in assessment phase, basically this is first time you're taking a look at your data. Your data is sitting in your initial staging environment, and you scan through this data to really see what is the current health of this data. You try to see the data standards within this data against your already established data standards within the organization. You try to really integrate certain data points that you have in this data with your metadata repository and see if there is meaningful information that you can leverage from your metadata management repository. And the most common way of doing that is data profile. People run data profiles to really understand the characteristic of their data. You also want to make sure that data is coming from right sources. And once again, the way you will do it, you will actually scan the information about data sources for this data in your metadata repository to be 100% certain that data is coming from right source. And then we have defined phase, where IT will start working with business stakeholders to really start doing the classification around that data. It is quite obvious that you cannot really justify the need financially or otherwise to have the same kind of quality for every data element. There are certain data elements where you cannot really afford any data quality, and there are certain elements where you will be all right with a little bit of variance. And that classification should be done with the help of business. You define certain kind of cleansing and data quality standardization rules, where again business will play a key role. You define certain policies, you define certain tolerance level around various data elements that you are trying to deal with, and then finally you establish an ownership. Again, the question of ownership will have an integration point with your data governance framework. And finally, you start acting on everything that you have defined so far. And this is again going to be slightly technical process where your IT will start applying the rules for cleansing and standardization. And they will also introduce a validation process. They will introduce a validation process that should kick in after every time your data storage, whether it's a data warehouse or data mart, or maybe some kind of analytical model based storage, should have validation process. And then you basically capture that information and start measuring the quality of data that will be presented in your learn phase within your quality reports, within your trend dashboard, within your policy dashboards, within your domain dashboards. So there are two things that will come out of this. If your quality is going upwards within a specific data domain, that is going to increase the trust of your business stakeholders in the information that they are using to make business decisions. And if it's really not going upward, if it's going downwards, then obviously that's not a good thing. But that can be an input that your IT and business group can take and go back to assessment phase and try to figure out that why we are not seeing the result that we expected to see. Maybe there was a flaw in assessment phase, or maybe the definition of that particular data element or that particular business rule was not correct as it was thought it was correct initially. So again, this picture shows that data quality is a continuous improvement type of cycle, and it should be considered as one. So that brings us to data profile. I wanted to have one slide dedicated to data profile, since I spoke about it a few times, as well as this is really a wonderful technique to reduce the cost of ownership, to be honest with you, of several IT and information management projects. So there are two ways of managing quality in your organization. One is an expensive way, another one is less expensive way. You can choose to take care of quality in a reactive way, in which case you just wouldn't worry about quality. You will get the data from various data sources, you will do integration, you will do some transformation, and you'll present that information on your information delivery layer, which means that a business user is seeing that information in analytics and reports and dashboards now, and perhaps making certain decisions on that. And at some point in time, somebody realizes that data that we're seeing is not correct. There are some quality problems with that data. And that will trigger the whole conversation between the business stakeholders who have direct interest in those specific data elements and an IT group. And people will work together, put together some kind of data quality rules, and next time they will hope to eliminate those issues from that particular aspect of data. But you're really not touching other data sets. You don't know what quality issues are there and when they will pop up. So that's a reactive way of trying to tackle the data quality. The other way is preventive way. So again, going back to the previous slide, the assessment phase will help you establish a baseline of how your data is and how is the health of your data and what kind of potential issues you can have and how to fix those issues. And the most common technique that is used in order to achieve that goal is data profile. So this is a de facto preventive technique that is being used across the board. It helps you detect data anomalies. It helps you identify the data set where you think there is a data problem, and there may or may not be. In some cases, you will see some we'll see some technical problems, and they will be able to fix those problems by themselves, such as if you see a data record where in a percentage column a value is 116, you know that there's a problem there. And that is something that you can fix by yourself. But you may also see some data issues that are more business focused, that are more business specific, and at that point in time you may need some help from business to really figure out what should be the right course of action. So once you have this data anomaly that you have detected, it gives you an opportunity to work with your business stakeholders and identify data quality rules around that. What kind of business rule can be implemented to really standardize that data, to remove that data anomaly, or maybe data is so bad that you just want to drop that data altogether. And then data reverse engineering. So think about a scenario where you're trying to work on a project, you're trying to build a new data warehouse, for example, and out of several data sources, some of your data sources are legacy systems that were built 20 years ago or 25 years ago, and you don't really know much about how those systems are created. You don't know how data is structured in those systems, and there's not much documentation available as well. How do you really understand these legacy systems? And data profile can help you do that. Once you basically point your data profile tool, and mind you, most of the data integration technologies available out there do provide you data profile tools as part of their enterprise suite. So once you point your data profile tool to one of these legacy systems, you can do some metadata analysis. You can see what are the primary keys and foreign keys. You can see what's the relation between various columns. You can see if there are nulls available in certain columns and what needs to be done with that aspect of data. You can see what the column width is and so forth. So this really takes away a lot of pain that you would have to go otherwise to understand these legacy systems. And then there is this question of domain discovery, which is absolutely critical topic in today's world, where data security is such a major objective of any information management ecosystem. So I'll give you an example in this case as well. Let's say within your organization you have a policy that social security number of all patients who participated in clinical trial now or in the past should be masked. And it should be masked everywhere. It should be masked when this information is stored in a flat file, or it is stored in a database, or if you're using some kind of in-memory computing within your organization, that information should also be masked when the data is cached within that system. Now, in today's world, we all use RDBMS system. So you have rows and columns, and basically it's very, very easy to go through the column and see the column name that may be able to indicate that that particular column stores some kind of social security information. And here you go, that's what you were looking for. Now it's going to be easy enough to really put a masking rule around that. That is not a problem. But what if you are dealing with some of these legacy systems which were used 20 years ago to store some clinical trial information, and there was a common field that an operator at that point in time was using to not only insert free text comment but also social security number of certain patients. How do you really discover that subset from that common field? Data profile technology and various techniques that are available around that have the ability to identify that subset of data as well. So not to mention that after doing all of this, you will eventually improve the return on investment on your information assets, and hopefully you will also reduce total cost of ownership of your application development and management lifecycle. So let's take an example. Here's a screenshot that I wanted to depict to you guys. It's obviously based on some fake data here, but what you see here is that I ran a column profile that tells me that there are some null columns, or rather null records within state column. And that sounds like a problem to me. So when I do further drill down, it shows me exact records that are associated with that particular set of null records. And that should, obviously this is an alert that there is a data problem, but that should also trigger a conversation around how do you want to really handle that scenario. And this is something that you would have dealt later in your software development lifecycle if you have not really dealt in the beginning while doing the data profile. So how do you really manage data quality? We spent 15 minutes or so discussing what data quality is and what's the impact. How do we really manage it? So really there are 4 different dimensions of managing data quality: the value, control and governance, the business processes, and data movement. And as long as you have your strategy, data quality strategy that is covering these 4 different aspects, as long as you have processes covering these 4 different aspects, you should be fine. So classification of element is very important. It will be a mistake to really go into this whole data quality program thinking that you will be able to provide the same quality, same level of quality to every data element that lives within your organization today, or that will be used within your organization in the future. You will not be able to really justify the need for doing so. So start with classification of elements, and then have a separate data quality strategy. Data quality, just like metadata management, is again another thing that goes beyond data warehouse and business intelligence. If your organization is involved in building custom application, you definitely want to make sure that they are using high quality data. You want to make sure that your ERP systems are consuming high quality of data to let people create those meaningful, important transactions. And then you need a robust governance model. So creating a data quality program, improving the quality of data, and then sustaining the quality of data will be a carrot and stick approach. And carrot and stick approach can be effectively implemented within an organization only through a robust governance model. And then this is a very important topic, so definitely worry about intended versus actual usage. Remember, when you were in assessment phase, you were working with business stakeholders, and business stakeholders were trying to establish the actual definition of data quality as well as business rules that should accompany those data elements. That was intended use. Your business users told you what they thought people will be doing with that data. But once your program is live, once you have people using the system, definitely go back and check what is the actual usage of that system. And it's quite possible that actual usage has a variance from intended usage. And again, if that is the scenario, then question is that why is that difference? Is it because you did not really interpret the actual usage correctly in the beginning? Or maybe things have evolved. Now people are looking for a different purpose from that set of information. And once you have that information available, you want to come back and definitely try and figure out a way of improving things, which is, again, takes us back to the point of the fact that data quality is a continuous improvement process. And make sure quality is part of your SDLC. A lot of times, I have definitely heard this, I'm sure you guys have also, that people don't worry that much about quality of data because they are worried so much about delivering the project. That's really a very dangerous notion, because you definitely don't want to create a system which has quality problem and you have all your various business leaders trying to use that system to make business decisions. You're going to do a lot of harm to your organization by doing that. And then have some regular year-long audits. A lot of time it has been seen that IT works with business and they do an exceptional job creating a great data quality framework and launch it, but they assume that their job ends there. The fact is that no, it does not end there. And if you're not doing year-long audit, let's say twice or thrice every year, you will see that things will start slipping away and the quality of data will start moving downwards again. So this brings us to our next topic within our presentation, the impact of unstructured data. So what is unstructured data? In today's world, we all live in our comfortable RDBMS kind of structured world where you have data stored in rows and columns, you have SQL statements, you fire your SQL statement with a where clause and you get the data what you're looking for. Easy enough. But anything that is not stored in that format is unstructured data. And like I said before as well, that 75% of data within your organization is unstructured data that you have no leverage upon. So let's go ahead and take some example of what unstructured data sets are available out there. Your internal documents, for example, your emails, some of your legacy contracts that were scanned and stored in your enterprise content management systems, and your classic MS Office documents. And then how about media content? How about video files? How about podcast, images, as well as your sound files? And then coming from life sciences industry, what about this this increasing notion of figuring out a way to analyze medical imaging? There's lots and lots of various data sources creating these kind of images, and there's wealth of information encoded with those images that needs to be extracted and used in making business decisions. And then you have impact of web content, SMS system, your social media data sources such as Facebook, Twitter, YouTube, your RSS sources as well as your blog sources. And then this is very interesting topic, the machine content. As I said before as well, that most of the data even today is generated by humans. But in 3 years from now, 5 years from now, that scenario will change. And you can actually see examples of that taking place today. You have sophisticated MRI machines and X-ray machines that are capable of generating data and transmitting that data to various touch points. You have sensor-based data that is being generated. You have your mobile devices that are capable of capturing location-based data and then transmitting it back to various touch points. And now you have smartwatches as well, and your iPhone and iPad-based applications that are popping up every other day, where they can monitor some of your basic health information and transmit it back to your physician, where your physician can do little analytics to really understand what stage your health is. Maybe there is some value for pharmaceutical companies to really analyze that information and learn more about consumers, patients, physicians, as well as their own products. And there's so many unknown data sources that are being created. This thing, I was reading a couple of days ago that some researchers in Taiwan came up with what they're calling a smart tooth. And basically it's a very small microprocessor chip with its own local storage that can be embedded within a fake tooth and can be put in your mouth. And what it does is it actually captures your eating habits. And then when you go to your doctor's office, again, doctor can analyze that data to see what your eating habits are. So you really don't know 3 years from now, 4 years from now, 5 years from now, what kind of data sources will be around and what kind of information they will be producing. But again, coming back to the topic, you want to really collect all of this information and get in your collection layer. Within your collection layer, you can do one of two things. You can either transform this information, which means you can introduce some structure around it, and then it becomes your traditional data source that can be integrated with the rest of the information. Or you can actually put a text analytics on top of your unstructured data directly. Now, there are certain vendors out there who are really doing a great job in terms of creating this ability of text analytics. It's still not mature enough, but it has reached to a point where it can go and scan multiple unstructured data sources, and based on filter can find the relevant information that you can use for analysis purposes. So once you have either introduced the structure to your unstructured data, or you have put together text analytic layer on top of that, now you are ready to provide this information to your business users so that they can use this to make some meaningful business decisions. Now, why is unstructured data so impactful? Well, basically, this chart should give you some basic answer. Again, because 75% of your data is unstructured, and you have either no control over that or you have less control over that. And 25% of data is your traditional row column formatted data that you're using today. So in other words, assuming that you believe in culture of making business decisions driven by facts and data, you're still using only 1/4 of potential information available out there. So one reason obviously is amount of data and information that is broken down between unstructured and structured data. That is one reason why it is so impactful. And then if you look at the future growth projection of data in next 3 to 5 years, you will see that most of this growth is focused towards unstructured, which again underscores the requirement or need for creating some kind of data management strategy and architecture geared towards unstructured data specifically. And like I said, impact of new and unknown sources. I mean, talking about smart truth, God knows what are the other kind of sources that are being in work right now. 360-degree view. So if you are using 25% of potentially available data right now, and you add remaining 75%, that definitely completes the pie. So I'll give you an example of a product. So being in pharmaceutical company, you are very keen to know as much as you can find out about your product. You want to know what, how this product is really operating right now, so that you can try and figure out a way to make it better. So you go into your all internal sources and collect as much information as you can about your products. You get in touch with your peers, who are healthcare organizations that are paying for the consumers, for the consumer use of your product. You get in touch with physicians and get their feedback as well. And you believe that you have everything that you're looking for. The fact is that you don't have everything that you're looking for. But if you start going on towards external sources, let's say you go on Twitter and start scanning information about your products, or you go to Facebook and LinkedIn and start scanning information about your product, you will find information coming directly from the consumer of that information. And once you take that information and integrate it with already available information, that will complete your 360-degree view of that product's current behavior. And then competitive intelligence. Again, I cannot really speak on behalf of complete life sciences domain. With a pharmaceutical perspective, there is a high cost pressure. There's a lot of competition going on in terms of companies losing the patents, and competition between branded versus generic products. So formulating a marketing strategy that is also incorporating what your competitors are doing is extremely, extremely important. And there are some vendors who are really helping pharmaceutical companies do that. IMS is one of them. But there's also a lot of information available on through non-traditional sources. Again, going back to Facebook or Twitter or whatnot, you can really go and find out about your competitor products as well, of course, in an ethical way. Most of this information is public information anyways, and really figure out what's really would be the best course of action to fine-tune your marketing strategy in a specific area. So in terms of managing your unstructured data, there are three major considerations that you want to keep in mind. Architectural consideration: try to create a reference architecture. Try not to deal with unstructured data in an ad hoc fashion. try and define some integration processes, some storage framework in terms of how this data should be stored, where this data should be stored, etc., and try to find appropriate technology to really integrate this information with the rest of the information. If you are thinking about taking advantage of unstructured data, then there's a high possibility that you already have some kind of enterprise-wide information management platform available within your organization. And if that is the case, then there's a great chance that that particular vendor also offers you some kind of hook or plugin to manage unstructured data. And if that is the case, look there first instead of going out and try to procure a new product. And that way you can manage your technology management cost better. And then think about governance. As soon as the data comes in, you have to establish ownership of that data. Think about metadata integration points, as well as, again, going back to the data quality, think about what kind of data quality rules you need to really include. So really, once this data comes in, you have to make sure that data is part of your regular data management lifecycle. And then finally, make sure that you're doing everything with unstructured data in a compliance way. You are in compliance with FDA and other regulations, as well as you are sensitive towards your internal regulations. So this brings us to the last part or segment of our presentation, that is analytics. So really, let's start with analytics maturity framework. So here is a different version of pyramid that we saw towards the beginning of our conversation. And this particular pyramid explains the various stages of maturity that an organization can be on in terms of analytics. So starting with raw data, you don't really have much understanding around what is the potential of an enterprise information management system. You may have some people trying to do some silo data capture. Maybe they have an Excel sheet that they received from one of their coworkers. Maybe they procure some data from outside. They import that data in Excel. They do some cell merging, and they run their report. Very minimum value from business point of view. Then you get to the transform data stage, where you have limited understanding of what can be done with that data. So you have a specific business group who starts working with IT. IT starts collecting data from various sources. They do some extract, transform, and load processing, and they store that data in a common place. In third stage, you start establishing some key performance indicators. Your understanding improves a little bit. You start thinking in terms of creating some pre-built reports and basic dashboards. There maybe there's a need for one of your business users to understand how much a particular payer is paying for one of your medicine within the state of Pennsylvania. And that is a very basic business question that can be really answered with the help of a pre-built report. Or maybe you want to put together a basic dashboard that wants to track how a specific product of yours within a specific therapeutic area stacks against competition within the same geographical area. If you're doing better than your competition, that's awesome, show me green. If I'm doing worse but difference is less than 3%, then there's something that I need to be worry about, so show me yellow. And then if there's any other scenario, then just show me red. Now that is great. It definitely improves your understanding, but it's actually telling about the business events that have already taken place in the past. There's not much you can do about those events unless you get to the information layer and you improve your insight. At this point in time, you start doing some OLAP analysis and you start doing some visualizations. You start sharing information among various users within your organization. So once you see that you are not really doing very well against your competition within that particular state, you start drilling down and see what is the reason why I'm not doing so well against my competition. And you may see that you don't have enough physicians prescribing or writing scripts of your product, which should trigger subsequent question that why is it so? Is it because my marketing strategy lacks somewhere? Is it because I don't have enough people trying to get in touch with physicians? Is it because physicians see there is a problem with my product? and how can I really, what can I do to turn around this situation, which is where the whole analytical process starts. And you get to the knowledge phase where you have robust awareness. You start taking all of these variables that I just explained and create a predictive model, for example. You start establishing some correlations and you start getting some information to support some of your business decisions. And this predictive model basically can take all the known variables that I just described and calculate an algorithm to answer a question that what may happen if you actually introduce more boots on the ground. If you add more people to your sales force, will that really help change the situation? And then finally you get to the wisdom phase where you start taking some actions and start making some changes. Now you will have to take that action by yourself. You still need a business domain knowledge to take those actions. There is this new concept of prescriptive analytics, which is basically in works right now. It should be mature enough to be used within an organization in the next 3 to 5 years, where your analytical platform will be smart enough to give you a recommendation of business decisions that you can take to make things happen. But as of today, you have to make these things happen by yourself based on what you feel is the right decision in that scenario. So let's talk about business analytics as a framework. So going forward in the future, analytics will be in the heart of your business models. More and more companies will move towards analytical function. And basically analytics is considered a function and should be considered a business function rather than a technical function. So speaking of a function, there are 4 different areas where you need some kind of skill set within your organization to build a robust business analytics organization or function. You need analytical skills, you need business knowledge about your own business, you need statistical knowledge, that is if you are dealing with some kind of big data and big data based analytics, and those are the individuals who are also referred as data scientists. And then you need technical knowledge about how your technology functions. So like I said, that business analytics is a function. It should not be really considered as a technical operation. And that's where people really make mistake. It should also not be mistaken and be considered just an eye candy, flashy, good-looking graphs and charts and pies. It actually goes beyond that. And again, it is still evolving. It's a very new field. 20 years ago, there was nobody thinking about analytical functions within the organization. So if you really see some kind of silo organization within your company trying to do something with analytics on their own, yes, you understand that you can get more value out of that if you do it on enterprise level. Maybe that particular silo organization is not aware of that. But that's what your job is, to really make a case in favor of enterprise function. Now, it should be seen as a strategic asset. Keep in mind that your business analytics function can be as good as the people within the organization and how much of knowledge they have about your business. I've seen scenarios where a specific business unit is under pressure to develop some kind of analytics, and they get in touch with an external vendor, and that vendor says that that's fine, just give us the data, we'll put together this analytics for you in 2 days. And they do it. The downside of that is that in long term, this is not going to really work very well for you, because you're really not building the internal skills that you would need to support these kind of functions in a long span of time. Now, the successful organizations that have implemented analytics to really turn around their business in a positive way share some common characteristics. One characteristic that they share is that they all use analytics on an enterprise level. Analytics is a function that can really do wonders for you if you do not use it in a decentralized fashion. So again, going back to a normal analogy, that my right hand doesn't know what my left hand is doing, and vice versa, is exactly applicable to your business analytics function. The second is that they all have strong commitment from their senior management. Regardless of size of organization, I think we all know that a small group of people sitting right there on the top will be driving the culture of organization. They are your business leaders, they are your IT leaders, the rest of the organization looks up to them to really establish a certain kind of behavior. So make sure that you have a strong commitment from your senior leadership. And finally, all of these companies are very ambitious, they're all in growth mode, and they all truly believe in data-driven approach for decision making rather than opinion-based, I know everything kind of approach. And there's several driving factors for this analytical culture that is really making its way to almost every organization now. Big data and cloud computing being one reason, obviously. Change business model is another reason. The businesses are quite global now. The whole planet is considered a village. And then higher regulations, and regulations are getting higher and higher. Plus technology. Technology is really a disruptive force, and in many ways, in a good way. So those are some of the reasons why business analytics is getting so much of attention now. So that brings us to the last slide of my presentation, and I'm going to hand control over back to Brooke, and if there are some questions, and if we have time for questions, I will be more than happy to answer.
Thank you so much, Manoj. Wonderful presentation. Again, this is the time to submit any questions that you have to Manoj. If you do not have your GoToMeeting toolbar right in front of you, please feel free to send those to me via email. Just a few other quick housekeeping items. I will be sending out a survey to all of our attendees today just to get your feedback in terms of the presentation, and I will be sharing that feedback with Manoj as well. I know he certainly appreciates that, so be on the lookout for that email later on today. Also, again, Manoj was kind enough to provide us with a copy of his slides, which I will be sending out to everyone after today's call. Manoj, we did have 2 questions come in, but you had very thoroughly answered them in your presentation, so I think if we don't have any other questions coming through at this time, again, got a comment that you incorporated some great practical real-world examples, had a team that said thank you for that. But I know we are getting close to the end of our course here, so again, we do have a few minutes. Please feel free to send any additional questions that you have via the questions feature. But again, I will be sending out a survey to all of the attendees, again, just to get any feedback that you have on today's presentation. I'll also be providing all of our attendees with a copy of the presentation slides, which Manoj was kind enough to provide us with, but I'm not seeing any additional questions coming through, so I know we are getting close to the time. Manoj, thank you so much again. Very well-rounded, thorough presentation with some great practical real-world examples for our attendees today. So thank you so much for your time and consideration in putting this presentation together for everyone. Also a big thank you to our attendees for investing your time with us today. Again, we will be sending out a survey just to get any further feedback that you would have on Manoj's presentation, which I'll certainly be sharing with him. But again, thank you to our attendees for being with us today, and thank you so much to Manoj Vig, who is the Associate Director of Information Technology at Shire, for sharing his views and providing us with some great real-world examples of business intelligence, going through the information management life cycle, and then collecting, managing data, and distributing it to the actual decision makers. Thank you so much to everyone, and have a wonderful afternoon. Thank you again, Manoj.
Thank you.
Bye.